Hi everyone, welcome to SvyadhyayaHub channel. In our previous video, we discussed key features of MySQL and its important files, how it will work and how the important of the key features. Today, we are moving to a step deeper into storage engines, the actual component that decided how your data is stored, indexed, and retrieved. So it will be based on the storage engines. So think of them like example, a different engines in a car, how it will be performed based on different designed engines. Like that. So we have a storage engines in MySQL and how it will perform, and to understand, we are going to deeper learn here. Here mostly we have storage engines, 9 storage engines. Coming to learning path, what are all storage engines? Those 9. So here, storage engines details, what we are going to learn in a deeper here. What is a storage engine? InnoDB storage engine, MySQL storage engine, memory storage engine, archive storage engine, CSV storage engine, merge storage engine, federated storage engine, black hole storage engine. So how we can see these storage engines will available in a MySQL. You can execute show engines once you log into the uh, MySQL prompt, execute the show space engines colon. So you can find what are the available storage engines, what are the default storage engine. So you can see that. Coming to here, a storage engine. What is storage engine? Storage engine is responsible for how data is stored, organized, and retrieved in a database. Okay, it defines features like transaction support, indexing, and locking mechanism for managing data effectively. So when your application is connected to the database to store and retrieve and display and showing that how it has to execute backend, so that will be based on your storage engine table. Okay, so we have storage engines, as I told, execute the show engine command, it will be display the storage engines. InnoDB storage engine is a mostly used uh, all the applications because this is a default storage engine and most commonly used, supports transactions, means OLTP, online transaction protocol. So foreign key support and row level locking. Key points. Coming to key points, what exactly the InnoDB storage and key points? Why we have to use this InnoDB storage engine? Okay, so this is a basically default storage engine from the 5.6 version onwards. Ideally, it is a row level locking because of that is high concurrency application. So this is ideal for high concurrence application. Concurrence connections will come, right. So multiple connections one by one it will come. So for all these multiple connection or multi-user connection, we can use this because it's a row level locking. Majorly think that row level locking. So each person is connecting to the each row to do their activities. So that particular row lock for ACID transaction, ACID complaint. This is a ACID complaint. So your row level locking for the better performance and concurrent connections purpose. Crash recovery is enabled via redo logs. We have a redo logs. So crash recovery is there when your system got restarted abruptly or suddenly or something crashes up, and we can recover by using the redo logs. So it's about the foreign key, data integrity purpose. We have, foreign key, primary key. Okay, all the keys are there. So data integrity, if you are looking for the proper data, proper location, it has to insert means. So data integrity is important for the data integrity. So this is a keys. Keys are the main part of a database. So how we can create a table? If you create table name, so automatically it will create into the InnoDB storage engine because default storage engine is InnoDB until unless if you change the default storage engine to other storage engine. So once you create a table here, okay. So what are the files will be stored? So .ibd file contains table data and indexes. InnoDB file per table is enabled. There is an option parameter If InnoDB file per table is enabled, so each table will create with the .ibd. Okay, shared table space, IB data one, stored metadata, undo logs, and data. If InnoDB file per table is disabled, see, even if disabled also, here it is metadata will be stored in IB data one. Okay, next, my next is MySQL storage. Okay, so here, uh, older engine does not support transaction or foreign keys, but fast or read heavy operations. Okay. For heavy operations, when you are doing the OL AP operations, mostly OLTP also we can use, but it is a not concurrency applications. Okay. Uh, when you are using for read purpose, okay, your application is for read purpose, okay, you can use the MySQL storage engine because this is read heavy workloads. You can use that. So table level locking, okay. Uh, Here it is a table level locking, and always when user connected to the table, it will lock entire table. It is no support ACID transactions or no support foreign keys, but faster data retrieval because it is locking on table level. Portable file formats make it easy transfer table. So you can easily transfer this table. And when you are going to create table, end of the table script, you have to mention engine is equal to MySQL. Okay. So when you create a MySQL student table, so it will create three files. .frm is a table definition, but the current version, which version we are using, the no latest version from the 5.7 or 8 above version. So .sda, yeah, .sda is coming. Okay, .sda is a serialized dictionary information instead of .frm. So .sda is creating. So you can see the .sdi files instead of .frm. So for the MySQL, coming to exactly the three files no, were created that are .sdi file, .myd file, .myi file. Okay. So next, memory storage engine. Memory storage engine only store all data in a RAM. So what RAM capacity, how much RAM capacity you have, that much, no? Based on that, it will be stored. So it will not store on the physical area. Okay. So this is memory level, it will be stored. It is a faster access. Data is lost when a server is restarted. When the server restarted, data you will lost because it will be stored on the RAM. So when it will be stored on the RAM, memory level, right? So once you restart, it will be free up RAM. So once you free up the RAM, so there is no data available. Okay, so why we have to use the memory tables is a temporary purpose. It's for the temporary solutions and some applications require a temporary table. So we can use the memory tables. Data, so here coming to key points, data resides entirely in memory, making operations externally extremely fast. So if you are creating a memory table, so these operations will be extremely faster because this is not required in physical area. Data is lost when the server restart. So as I told, when the server restarted, data will be loose. Ideal for temporary tables for caching purpose and temporary table purpose. Support hash index by default, limited by the system's available RAM. So how much RAM is available based on the RAM, it will be limited to the storage. So when same here also, when you are creating a script, a create table script, when you are using end of the table script, engine is equal to memory. If you mention engine is equal to memory, so it will be create a memory storage engine table on the physical area. So in the physical area, here also one table, one file will be created. That is a .sdi for the current version, which we have 8 and 9. So earlier it was a .frm file. It is a table definition file. So no physical data, index files, data resides in memory only. Next, so CSV storage engine stores data in CSV. This is called as a comma separated value format. Useful for exporting and importing data and reporting purpose. If you see this CSV storage engine, it will create a file. Okay, a kind of flat file on the Linux machine. You see, on a Windows area, it will create a kind of a spreadsheet Excel. So when you open that .csv file, it will open on Windows as a Excel sheet format. If you open here Linux format, it will be in a flat file. Here stores data in a plain text. Told you right, it's a plain text, making it easy integrated with the external system. We can easily integrate with the external system. No support for indexes. Here, no support for the indexes. Suitable for lightweight portable data storage and slow for large data sets due to lack of indexing. So here is no indexes. When indexes are not there, if you want to use huge data table, so it is not suitable because when it is retrieving the huge data file, it indexes will provide faster, fetching data fetching. So limited to fixed width character sets for compatibility. Okay, so same. When you are going to use a create script for this, create table, table name, end of the script engine is equal to CSV. You have to mention. So here also on the physical area, three files will be created .sdi for the current version and the previous version 5.7 and 5.6. In the eight few of the versions, .frm will be. Okay, that is a variable definition. .csv, file name .csv, data file in comma separate format. Okay, so .csv metadata. So it is a meta information data file in a comma separated format. Okay, so next archive. Archive uses compression for storage data. So when you are writing on the table, inserting, okay, so this stores with the compression method. Here, the actual table will store with the compression method. Suitable for archival purpose where the data is mostly read and rarely updated. So if it is not updating regular basis, it is updating long period or once in a while. So we can use this archive. What it will do, the storage area, okay, actual storage, it will be not use the actual storage how much we are inserting. Okay, so this is good for huge data warehouse storages. So if you are not using, okay, so data warehouse application kind of thing, it is good. Key points desired for storing large volumes of historical or archival data. Suppose if we are not going to use, we want to store some historical data, years of data we want to store. Yeah, we can change into archive storage engine. So it will use the less no storage space. Uses row compression for efficient storage. Here, yeah. So how it will be compressed? The row compression method only supports insert and select. So mostly it support insert and select only. Updates and deletion, no, but rarely you can use. Read-only queries does not support indexing. Only for read-only queries does not support indexing except for the primary key. Best suited for logging or write once. Read many workloads. Many time you can read, but writes mostly less. Same here also, when you are going to create a table, use a create table, table name, end of the script, engine is equal to archive. So when you are creating the table, after creation of the table, so you can find physical files on the physical area .frm or .sdi file, table name .frm or table name .sdi. Okay. Here also data file, table name .arz or it will create. So data file always table name .arz. It's a compressed method. Next, federated storage engine allows MySQL to access tables from a remote MySQL server, useful for distributed application. So when you want to access remotely your SQL server, MySQL server, so this is a good, this is a more secure. This is used for distributed application purpose. So here, coming to key points, enables access to remote MySQL tables, without replicating data locally. So it will not replicate locally. We can access only remotely these tables, suitable for the distributed system requiring centralized queries. If you have your data need to be distributed in different areas, so this is useful. Does not store data locally. It will not store locally. It will act as a virtual table. It will act as a virtual table. You cannot no find a data file. Yeah. Say when you are creating table here, create a table script. Okay. Like table name. Okay. End of the engine is equal story engine, and you need to provide a connection string with the user and password with the remote host where the database is there, which user, the password of the user, and the remote host name you have to mention when you are creating a table. Data files here, .sdi, table name .sdi, table name .frm will create based on the MySQL version. So no data or index file locally, data fetched from the remote server. Next, black hole. Accept the data but does not store it. So here, when you're using the black holes, you can insert the data, but when you're retrieving, it will show empty set. So why we used to this black hole storage? There is a security reasons. There is a purpose. So when we are using the replication servers, we can no store data in a master black hole storage engine and converting to we can use a different storage engine. Use it for the logging or replication purpose. Logging and replication purpose. Also, this logs, see binary logs there. If you enable the binary logs, the data will be stored in a binary logs, but it will not store on the table level. Key point, accepts data but does not store it. See, as told, data will be accepted when you are inserting, but it will not store on the physical area because it's empty set. This no feature is empty set. It will not store any physical files. It marking as a data sink. Marking it a data sink. Often used for replication and logging in master slave setups. When you are using it, often used. Inserts are accepted but discarded immediately. Inserts are accepted but immediately discarded means it will not store. Select queries always return the empty results. It does not create any physical data files. So it will not create any physical file because it is not storing any data on the physical area. Same. When you are going to use a create table script, create table, table name, engine is equal to black hole. The same here, the files will be created, only one file will be created, no physical data, no index file here, only table name .frm or table name .sdi. So these two, one file will be created here. Merge mechanism. Next is a merge mechanism. So it's a combines multiple MySQL tables into a single logical table for partitioning or table union purpose. So here, merge MySQL is a combination of MySQL tables, a union of MySQL tables. So this is used for a union of your multiple tables. For example, I want to see like a uh, what is schools. If you go different section, different classes are there. Okay, one class having a different section. You want to combine all the sections into one table, so you can use merge MySQL storage. So like that combines multiple MySQL tables into a single local logical table. All underlying tables must have identical structure. Supports read, write, and index operations across the combined tables. Read, you can do that. Write, you can do that. Also, index operations also across the multiple tables. Ideal for managing the partitions and large data sets. When you are having the huge data sets, so you can combine these. So this is for large data sets. You can use some merge MySQL storage. Merge table does not store data. Okay, it reference underlying tables. It reference underlying tables which you are using the MySQL tables. Same here also table script. When you are going to create table, create table one, table two. Okay, each table you have to union. So how you are suppose you are going to create a MySQL table. You have to create a two MySQL table or three MySQL tables, whatever how many you want to. So then you want to union those things. Suppose I have a sections. I want to create A section, B section like the tables, and you can union for the entire class. So how you can create table, merge table. You name that name, depends on your table name. Okay, so each table merge Indian is equal to merge, and then after union is equal to the table 1 and table 2 insert method last. Okay, if you keep the insert underscore method is called last, means what will do, table 1 will be first, table 2 be in the last. It will inserted. So merge table only .frm will be created because underlying margin tables .frm, .mbed and mbed files. So .frm table name .frm or table name .sdi file. So remember that the latest versions are having the .sdi file, older versions are having the .frm files. Thank you so much. Subscribe and waiting for next videos.